The thickness of a sheet of aluminum foil is to be monitored using beta radiation as illustrated. The separation of the rollers is controlled by the output of the detector with the intention of maintaining constant foil thickness. State what would happen to the separation of the rollers if the output from the detector were to increase. Increasing output from the detector means it receives more beta particles. This happens because the rollers are too close together, causing the foils to be thinner. A feedback signal will be sent to the roller to increase their separation so that the aluminum foil will become the same thickness as before. Suggests why a gamma radiation source would not be satisfactory for monitoring changes in the thickness of the foil. Gamma radiation can easily penetrate thick aluminum foil, hence the count rate registered at the detector will not vary with the thickness of the foil. A beta particle source of half-life 14 days is installed in the monitor and then used for a working day of 8 hours. Calculate the ratio of the activity of source at end of working day to the activity of source at start of working day. Now this is the equation we can use. The activity equal to original activity multiplied by e to the power minus lambda t, and lambda is ln 2 over half-life. So substituting values, we get a ratio of 0.9836. Now it's good to know that the n over n naught is equal to a over a naught equal to e to the power minus lambda t, and lambda is equal to ln 2 over half-life, and this is also equal to 1 over 2 to the power x, where x is the number of half-lives. So if we ln both sides, then for this expression, then we will get minus ln 2 over half-life multiplied by time equal to minus x ln 2, and then x will be equal to the simple ratio of time divided by the half-life. So using this method, we can calculate x, which is 2.38 times 10 to the power minus 2, and then the ratio of the activity will be equal to 0.9836, same as before. Estimate the percentage change in foil thickness during one working day. If no allowance is made for radioactive decay, state whether the change is an increase or decrease. Since the activity is weaker, the detector will register a weaker count rate. The system will perceive a thicker sheet. Hence, to correct for it, a feedback signal will be sent to decrease the separation of the roller, which will reduce the thickness of the aluminum sheets. Let the strength of the signal sent from the detector to a roller S, that is the change in thickness of the sheet, to be proportional to count rate registered by the detector C. Furthermore, let C be proportional to the activity of the source. So since S is proportional to A, we get delta S over S of fractional increase will be equal to delta A over A, and that will give us a ratio of 0.0164. So the percentage change is about 2%. Discuss the advisability or otherwise of using a beta emitting source which has a high activity, giving count rate many times that of background. The fractional error in count rate will be reduced since the count rate is high. If the sheet is thin, the detected change in count rate will be more significant. That is more sensitive monitoring. However, high activity may also pose a health hazard. Discuss the advisability or otherwise of using a beta emitting source which has a short half-life. If the half-life is short, the activity will decrease quickly and adjustments have to be made frequently. Also, the source may have to be replaced frequently as well.